All right, hello everyone, I'm Keith Casey. As he said, I'm here based in Austin, Texas. So a few things about me. I do live here. I used to run the API meetup here in town, ran that for a few years. Because before that I came from a company called Twilio. Most of you have probably heard of it by this point. When I joined it, nobody had heard of it. It was just like this strange little API company. There were 25 of us. We all fit in one room. And now I think they have something like 2,000 people. But more recent times, I've designed and built APIs all over the place. Large-scale companies that you've probably heard of, tiny companies that unfortunately have gone out of business, basically everything in between. My current job is at Okta. My title at work is the API problem solver. And I do mean that quite literally. That's on my business cards and everything, so it must be true. And one of the things that when I talk about API design and sort of how it works and how it's approached, I tell people that I wrote the book on API design. And I say that because the URL. The URL is theapidesignbook.com, not another or some API design book, but the API design book. And actually, I'm being kind of disrespectful. My co-author was here yesterday morning, James Higginbotham. So if you met him yesterday, we've been working together on that, done some great work around that. But really what it comes down to is that I love breaking things. I love getting in trouble. I love causing trouble. And in fact, I've had a number of good friends sort of think about how I approach data and APIs and figure out how can we abuse this. In fact, there's prominent people in the API community that just don't share data with me anymore because when I get a hold of data, I cause all kinds of problems with it. So with that mindset, I get to advise our customers. I get to sit down and see, like, what are they doing? What are they doing that they shouldn't be doing? What are they not doing that they should be doing? Like, how can we make this world a little more amusing? I mean, a little more secure. So that's kind of my approach on things. And normally one of the big questions I get when I sit down with all these customers is, what the hell are you doing? Because I'm the guy that will sit down with Postman and start connecting to the API, even though we're not supposed to. Because the bad news is that the vast majority of APIs out there are not secure, even in the slightest. So with that, I want to talk a little bit about failure. If we stop and think about how API breaches happen, how the big security breaches happen, there's too many to list. If we even just limit it to the last 2 years, they're catastrophic and they're getting bigger and bigger. And I don't just mean in terms of the number of customers affected, I mean the type of data affected. You know, my favorite on here is actually Tinder, for different reasons. But the amusing thing about the Tinder API is that they didn't actually have any authentication built into it. So you could send messages as somebody else. It's a silly use case, right? That's a silly scenario. But fundamentally, you can cause a lot of problems with that. And then we kind of step up and we say, okay, well, what about Delta? Delta had scenarios where they were releasing loyalty accounts, like loyalty information, so that with just a little bit of information, I could then query and say, when are you traveling? When do I know you won't be home? Even more fun, can I get your confirmation number? Because with many, many, many airlines, if I have your first name, last name, and confirmation number, I can cancel your flight. Is that a problem at all? I think it could be, especially if I wait for you to get to wherever you're going. Equifax is the 800-pound gorilla of the bunch. I'm not even going to touch that one because it's just I don't want to end on a depressing note. But let me talk about this and say the vast majority of API vulnerabilities happen for good, honest, they at least happen for honest reasons. It's because when we stop and think about APIs, it's very rare that the CEO, the C-level executive walks in the room and says, we will have APIs. Yeah, it happens a little bit. But more likely what happens is the vast majority of APIs come from the bottom up. It's because your team of 5 developers is building something. And you've built the same thing over and over and over again, and you're getting irritated. You're saying, I want to build this once and be done with it. And so you build it once, and you say, okay, I have 5 users. I can look around the room and see my entire user base. I don't need to worry about authentication. I trust everyone that I work with. Well, that's successful. That works really well. People are really excited about it. They're like, wow, this API, we're able to move faster in our projects. We don't have to refigure this out every time. And another team learns about it, the team down the hall. The team down the hall comes to you and says, hey, I heard you had this API. We were thinking about doing that, but you've done it. Can we just get access to it? And you say, hey, look, your coworkers, we trust you, we see you in the lunchroom all the time, and they go ahead and give you access. So we go from 5 people to 5 teams. Okay, that's great. Well, at some point, we have an architect get involved. And an architect says, well, we need to start thinking about governance and versioning. We need to put an API gateway in place. We need to think about these things. And those are all great. Those are all fantastic things to have. But eventually, that architect's boss, the VP, says, well, wait a second. These internal teams across campus and that other building, actually, a lot of our partners have similar use cases. Our partners need to accomplish very similar things. Can we open it up to them? And we say, absolutely, because as software developers, we have 2 goals in life. Does anyone know what those 2 goals are? Every single one. They apply to every single person in this room, I guarantee you. 2 goals in life. We want to build something useful, right? We want to build something useful. We want to know that our work, that our time, that our effort is valued. And the other goal is to go home. That's it. Those are our 2 goals in life, right? Now, you could go home because, you know what, I've got other things to do, I've got family, I've got friends, whatever. I don't care. We want to build something useful and go home. The best single metric of building something useful is more people want to use it. If you come into work on Monday, and then you come back on Tuesday, and there's more people using your software, or using your docs, or using whatever, you're happy. Because you know your work is valued. So when we're looking at this, we go, wow, my team found it valuable. The 5 people on my team, they found it valuable. Those 5 other teams, they found it valuable. Those 5 partners, they found it valuable. I'm successful. Well, at this point, a C-level exec gets involved. They come back in the room, and they say, hey, I was just at this retreat. We were talking about digital transformation. And digital transformation is a wonderful thing. It's driving the future, blah, blah. And they feed you that line of bull. But what it means is that those customer use cases, the top tier customers, they look a lot like partners. And they want to accomplish many of the same things. And they want to do these things. They want to tie in. They want to integrate data. We want our product to be stickier. And so we're like, hey, this is fantastic. And so we tie in our top tier customers. And it turns out, James was on stage talking about this earlier, our top tier customers and our next tier customers, they actually look a lot alike. There's not a big fundamental difference between most of those. So it goes from our top tier customers to all of our customers, like that. Now remember, that's still more people using our API. That's more success, that's more excitement. We're happy because more and more people are using our API every day. We've won, right? Well, here's the problem. We get close to that C-level executive saying, hey, look, we're launching the API in 30 days. And they go to the security team and they say, hey, security team, we've got this great API, we're launching it in 30 days. We need you to do a security review of it because we're launching it to the public. Anyone can use it, but don't worry, it's probably secure because we've been using it for a year. There's one phrase of that entire thing that your security team heard. What was it? We've been using it for a year. Because they go, what the? That's their reaction. Because they know that any sort of vulnerability, any sort of issue that they find here at this stage, one, they have to convince their C-level exec, hey, look, don't launch that thing because we need to fix it. But more importantly, they know that every vulnerability that they find here actually existed the whole time. And the reason this happens is really simple. It's because when it was 5 people, when we could look around the room and see who's using our API, we didn't worry about security. When it got to be 5 teams, we couldn't look around the room. We couldn't reach out and slap the person that's misbehaving. But we never stopped to reevaluate security. When we then go to 5 partners, and we can't even name the people using our API, maybe we can't even name the partners, it radically changes things. When we open it up to the whole freaking world, we have a problem. We never stop to think about, do these things still make sense? Are we still insecure in what we're doing? Is this going to be the next Panera? This is actually how Panera worked out. So the exact path that they took. And fundamentally, I'd wager every single company up there and every single one of you have gone through this very similar path. Okay, so how do we do this? How do we fix this? So I sort of boil it down to 4 aspects. The first one is we only want to expose the interfaces that we need. So we're not going to expose our entire API at once. We're going to expose the individual pieces relevant to the individual use cases that we're solving. Okay, Pretty simple and boring. Next one is, let's only collect and share the data that we need. If we don't need it, don't collect it. If we haven't collected it, it can't be breached, right? We can't leak something if we don't have it. And then once we do have something, if we don't have a reason to share it, don't. At Okta, we do authentication, username and password. Once we accept that password and we hash it, we never give you that hash again, because that's something that could potentially be compromised. By not sharing it back, we don't have to worry about that. And the other thing is, we only want to grant access to the people and the systems that we need. We're not going to publish API keys to everyone. We need to stop and think, who do we want to have access, and is their use case valid? And sometimes the answer is going to be no. And that's fine, but we need to draw these boundaries. Actually, wait a minute, wait. We're software developers, right? Software developers, what number do we always start counting with? 0! So I actually skipped 0, because I think this is the most important factor more than anything. And that's because we need to think like a bad guy. If we stop and think like a bad guy of how could somebody misuse and abuse this API, this data, that's way more fun. I mean, that's way more effective at figuring out what can actually happen here. So the rest of the time, I want to talk about thinking like a bad guy, because that's way more fun. I mean, effective. So let's talk about how. First of all, I say always read the news. Look at competitors. Look at our peers. Look at the people in the space and see what breaches they've had. See what things they've struggled with. Let other people learn these lessons for us. That's the best, fastest, easiest, cheapest, least career-damaging way to learn things, is watch other people screw up. Next up, talk to your legal and compliance team. I know no one loves talking to lawyers, right? Just stop and talk to them. Actually, they have a really important job. Their entire focus in life is to protect the organization. Security, isn't that a piece of that? We just need to go and talk with them. Say, hey, what are the things that keep you up at night about data, technology, those sorts of things? The more we can do that, the better off we'll be. And by the way, if we have good relationships with them, when we do need a favor, when we do need to ask for help, we know who to contact. That makes life way easier. Next one is talk to your existing team about horror stories. Now, I know your current development environment and your current security posture is fantastic, okay? But odds are that last place they came from, it was a shit show, right? Everyone has those stories. Well, there was this time we were using social security numbers for passwords. That was actually one of my employers like 15 years ago. Those are the kind of things of, they make us cringe on the inside, and we kind of think about those things and we still get that tight stomach thinking about it. You know what, we all have those stories. Bring them forward, talk about them. Figure out, oh, wait a minute, are we doing that? Ooh. If we discover this internally and have the chance to fix it, that's fantastic. That means some random knucklehead on the internet can't cause that problem for us. But actually, my favorite approach is write a Black Mirror episode. Is everyone familiar with Black Mirror? Is anyone not familiar with Black Mirror? Black Mirror is this, it's this postmodern approach of technology dystopia. So it's the idea of, what if we had the existing technology we had and we took it 2 steps further in a horrible, awful direction? Is that fair? Is that a good description? Okay, cool. So yeah, let's take our API and say, if somebody got a hold of the data here, what could they do? The Equifax data is fantastic for that. You know, when you create a new bank account, they say, what street did you grow up on? And what color car do you have? And stuff like that. Well, with the Equifax data, I can answer that question for anyone in the room. Oops. That won't cause a problem at all. All right. So part of this is also we want to think about what a bad guy actually wants. Because saying, oh yeah, they want our data, yeah, well, that's right, but that's not specific enough. Let's get a little more specific. A bad guy wants valuable data. Duh, obviously, that's why they're coming after us. More importantly, they want accessible infrastructure. They want to be able to access something that we weren't expecting them to. That's good. They want to be able to have a simple or even no authentication or even authorization. That was the source of the Equifax hack. Is you could, once you authenticated as whatever user you wanted, there was an ID in the URL. And you could use the crazy hacker method of incrementing to go through their entire database. because there was no filter saying, you know what, Keith can access this record, but no others. So another good hacker method, incrementing. Keep that in mind. Next up, bad guys love custom-developed authentication and authorization systems. They love those because you know what? Odds are we screwed it up somewhere. That's a safe bet. I gave a presentation like this to some people from the NSA, and I said, look, unless you're a crypto expert, don't build your own. And they go, no, we don't build our own either. This is useful to remember. Let other people make mistakes and learn from them, please. One good thing that all bad guys want is they want to act undetected. The longer they can act undetected, the better it is for them. The worse it is for them. But the source of the Marriott hack, they actually had, hackers had access to the network for, I think it was 4 years. Just think of all the fun you can cause with 4 years of data. Yeah. All right, so a couple concrete steps I do want to share is I say absolutely use an API gateway. It's not because I love API gateways, it's because they solve a particular class of problem and they do it well. So I don't particularly care which one you use, but they are useful. So it kind of breaks down into 5 pillars. So you've got life cycle, and they do like where is it deployed, how is it deployed, what state is it in, production prod, or production beta, that sort of thing. Interfaces. This is where they lock down and say, what do we have access to? And that's an important thing. Every API gateway, you can say, look, only grant access to this endpoint, and only allow verbs of these types on this endpoint. That's good. If we allow everything to everyone, well, I guess that's job security for me. So definitely do that, okay? Next up is every API gateway does some sort of access management. This could be as simple as API keys. This could be OAuth. Most of them have a built-in OAuth authorization server. That's fantastic. That's a starting point. Obviously, I'm biased. Don't just stop there. Look into an identity provider. But the more you can sort of limit your access to specific things, the better off you'll be. This gets back to limit access to only to the systems and people we want. And then gateways also handle consumption and business and things like that. I'm not going to worry about that here. Next thing is, we need to be smarter about our data. We absolutely need to be smarter about our data. Like I said, if we don't have to collect it, don't. We cannot be breached. We cannot leak data if we don't have it. That makes life easier. You know, when your legal compliance security teams come through and they go, well, how are you handling PII? It's a really easy answer to say, we don't have any. Love it. That's fantastic. I was working with a large financial institution recently, and they're like, oh, well, we only keep this user identifier. And I said, okay, cool. The only way you can translate that into a user is with your Okta API key, make a request to us, and now you can, okay, cool. So now you have, to figure out what that actually means, you need 2 pieces of information. Okay, that's a little better. Just compromising your system doesn't give people profile information and addresses and email addresses. That's fantastic. And when possible, encrypt it at rest. If you have to keep PII, if you have to keep healthcare, financial data, encrypt it whenever possible. Now, if you store the encryption key with the data, you've defeated the point, okay? And I'm not saying that any company has ever actually done this, but just keep that in mind. Do not store the keys. You know, if you took your house key and taped it next to your door, that's not useful. Don't do that. Don't do that with your encryption keys either, okay? Next up, absolutely please stick to the standards. Don't get creative here. The 2 big ones are obviously OAuth, and on top of that, OpenID Connect. Daniel said earlier, like most people look at these standards and are like, oh, I can implement OAuth Core. Maybe, but don't. Because one of the nasty, ugly things that's actually built into that is OAuth itself it's a framework and has all these pluggable pieces. And when you stop and see all the pluggable pieces that are available, there's a lot of them. These are, let's see, I think these are just the ones out of draft status, but there's dozens more. Most people say, oh, OAuth has to be a JOT token. Well, not really. The core specification doesn't say. That's an extension. That's RFC 7519, I believe. Like, these are the kind of things that, yes, you could build the basics yourself. Don't. You will screw it up. Use a vendor, use an open source project, do something. Do a security validation of the product you're evaluating. Absolutely do that. Don't build it yourself. And here's one cool thing. I was working with a large financial institution recently, and they said, oh, we're going to build our own OAuth libraries. I said, please don't. Please don't. Take one of the existing ones. This was for mobile, so they were looking at the AppAuth library specifically. I said, use the AppAuth libraries and do a security audit of those. One, now you don't have to build your own, assuming they meet basic specs. And if there's any issues, report them back to the team, submit fixes if you're really motivated, and now the internet as a whole benefits. That's the point of open source, right, folks? This is what we want. This is what we need to do. We can't just consume and use stuff. We need to actually say, hey, what's out there is already good. Let's reuse that. Let's contribute and improve that when we can. And next up, I always say we have to integrate into existing processes. When we're building APIs, we think we're cowboys. We want to go off and do crazy things. Remember, that's how we started. We built the API for 5 people, and it worked out well. Well, you know what? Odds are our security and compliance team, our network operations team, have processes. So at some point in there, we need to pause. We need to go, how can we plug into our existing systems? Because when the bad news comes, let's be honest, when that API breach happened at Panera or Equifax or Twitter or whatever, they don't go to the developers and blame them, do they? They don't come to us. They go to the security team, and they go, security team, it's your job to make this secure. What happened? As the security team goes, what API? That's our fault. That's our fault for not involving them, for not plugging into their existing systems. So fundamentally, let's think of it at a personal level. I'm risking your job to accomplish my job. We have a word for that. Asshole. Right? If you look at anyone on your team and say, yes, I would purposely risk your job for my job, you're in the wrong business. Stop. Get into something else. Get into consulting, okay? Oh, that was rough, wasn't it? But this has some upsides. So last August, there was a hack of T-Mobile. T-Mobile has something like 77 million customers, something like that. Well, when they launched their APIs, using us, I'm kind of biased, but they were plugged into their network operations team. And so they were under attack, and they had these crazy hackers using that increment method trying to get access to things. Okay, so there was a problem in the development process right off the bat. Totally agree. But their network operations people detected it, and they said, whoa, wait a second. This doesn't look like normal user behavior. And because it didn't look like normal user behavior, they were able to stop it in process. And so the attackers only got 7% of the database, not 100% of the database. Still not great, but a lot better than it could have been. And by the way, these guys are heroes now, right? This is the kind of people who are like, wow, fantastic, you're doing great work. These are the things we need to watch out for. We're a team, right? If we screw up the team down the hall's job, come on. Nobody needs that. Nobody wants that. We need to think more about that. So let me leave you with some closing thoughts. So I say, fundamentally, when we're thinking about API security, we want to think about, like, what's the worst possible thing somebody can do with this API? We need to think about what happens if our competitors get our data. What happens if they use that crazy hacking method of incrementing to download our entire product database or our customer database or our item database, whatever the case may be. We need to stop and consider what happens there. But before that, we need to stop and say, what data do we actually need? If we don't need it, don't collect it. If we do need it, we don't necessarily need to share it back. Make sure that that data is segmented and clean and not being broadcast back where we don't expect it to be. Next up, who are our users today, right now, this immediate moment, and who will they be a year from now if we're successful? If this is a product, if this is an API that's driving usage, adoption, and growing all over the place, we should assume that more people will be using it tomorrow than are using it today. And we need to stop and think about that. Not just the numbers, but who. Because partners using our API probably don't have the same security posture as we do. And we need to stop and think about that. And then finally, we need to stop and think about how are we monitoring it? So are we plugged into something like Splunk for network operations? Like, how are we stopping and thinking about this? Because the better off we do this, the better life will be for all of us. And security as a whole can benefit. So with that, I want to say thank you and have a good one.